because it only affects the action through the endpoints, and the rule is vary the trajectory keeping the endpoints fixed.
So S can be any scalar?
S can be any scalar. But this is exactly the operation of putting in a derivative, adding a derivative to the action. Adding a derivative to the action typically doesn't change anything because you can do the integral, putting a derivative into the Lagrangian doesn't change anything because when you integrate it, it just gives you some endpoint contributions. But here it is. All right, so what we've discovered a principle of invariance, that the motion of a particle in an electromagnetic field does not change if you take a mu to a mu plus ds by dx mu. For any s, doesn't matter what s is. This is called gauge invariance. This is the concept of gauge invariance, that the vector potential itself can be changed without any effect on the behavior of the particle, of the charged particle. Certain changes, not every change. Certain changes, those which are ds by dx mu. All right, so adding a ds by dx mu to a vector potential is called a gauge transformation. Where the word gauge came from, it's a historical artifact that had nothing to do with anything. It just became a terminology for some confused reason in the beginning of the 20th century. This was called a gauge transformation, and it stuck, but it doesn't really have anything to do with gauges. Gauges meaning things that measure length. That's what it had to do with. You fail this course if you say gauge transformation. That's one of the main criteria. You say nuclear or gauge. Okay.